And so now we're going to look at some related rate problems that deal with word problems. And I've put together a few steps to take into account when you're doing these. First, identify all the given quantities and the quantities to be determined. Within this step, a lot of times another thing you may do is draw a picture and label that picture with those things that we know. All right. Write an equation involving the variables whose rates of change either are given or to be determined. So we have to write an equation with those variables that we've established. 3. Implicitly differentiate both sides of the equation with respect to time. That's what we did in our problem number 1, taking the derivative of both sides with respect to time. And then we're just going to substitute the things we have listed from step 1 and solve, kind of like we did in step 1. So the first 2 steps here are new from the last problem we looked at. So let's first read through this and figure out what we're dealing with. A ladder 26 feet long leans against a vertical wall. At a particular instant, when the foot of the ladder is 10 feet out from the base of the wall, find out how fast the top of the ladder is moving down the wall. Assume that the foot of the ladder is being drawn away from the wall at a constant rate of 4 feet per second. So let's get our drawing together here. We have ground there, we've got our wall, and we have this ladder. So we are standing over here at the ladder. This ladder is 26 feet long. Right? It says it's 10 feet from the base of the building. And it tells us that the foot of the ladder is being drawn away from the wall at a constant rate of 4 feet per second. So that means the bottom of the ladder is moving in that direction at 4 feet per second. So now we want to kind of label these things. We kind of put them into our drawing, but what are we dealing with here? Well, we have a right triangle that we're dealing with. So I'm going to start off by labeling the 3 sides. I'm going to do the horizontal side here as X, vertical as Y, and I'm going to make the ladder Z. So we know X is 10. We don't know what Y is right now, but we can figure that out. Z is 26. So Y, we can figure that out pretty easily. Since this is a right triangle, we can use Pythagorean theorem. Right? 10 squared plus Y squared has to equal 26 squared. Or if you know your Pythagorean triples, you might be able to figure that one out without doing this. But for this, if you solve that equation, you should get Y equals 24. Right? This is a 5, 12, 13 triangle. So we have our 3 sides, and we're given this other piece of information here, this 4 feet per second. What that is our dx dt. That's the change in x with respect to time. Right? X is changing, this distance is changing at 4 feet per second. And since that distance is getting bigger, that means this is going to be a positive 4 feet per second. If this ladder was getting closer to the wall, X would be getting smaller, so this would be negative because it would be decreasing. Now, we're going to look at what's dy dt and dz dt as well. Right? Look at each variable and their change. Well, with dz dt, that's the ladder. Even if we're moving that bottom out, that ladder is not changing. Right? The size of that ladder is not going to change at all. So dz dt is 0. Right? It's not going to change. It's constant. dy dt is the thing that we're trying to figure out. It's asking us to find out how fast the top of the ladder is moving down the wall. So we're trying to find dy dt. Since y is getting smaller in this process, right, the ladder's coming down as this is going out, dy dt, we should expect that to be a negative value. So let's go ahead and try this out. Next step, right, we've done the first 2 steps. The first step, identified all the quantities and what's to be determined. Second step is to write an equation with those variables. So we've got x, y, and z. Well, we've already kind of used an equation to solve for y. So the equation that we're going to deal with here is Pythagorean's theorem. right? That's an equation that represents and like ties all three of those variables together. So we wrote our equation. Number 3, we want to implicitly differentiate both sides with respect to time. So we're taking the derivative of both sides with respect to time. So taking the derivative in terms of time on both sides. Well, derivative of x squared would be 2x dx dt, plus derivative of y squared is 2y dy dt, and derivative of z squared is 2z dz dt. So we've taken that derivative. The last step is to substitute and solve. So we're going to take these values that we've written down and gotten from the problem and figured out and substitute them in here. So we have 2 times 10 times 4 plus 2 times 24 times dy dt equals 2 times 26 times 0. So over here we have 80 plus 48 dy dt equals 0. So we can solve for dy dt, subtract the 80, divide by 48, and we get negative 80 over 48, which simplifies to negative 5/3. So for this one, our answer needs to be labeled. We have negative 5/3 feet per second. So the ladder is moving down the wall at negative 5/3 feet per second.